So modern websites, they're big and they're complicated. So I just loaded up YouTube here on my laptop and it did 157 different web requests to a whole bunch of servers. So how are modern websites able to serve all of this content to you so quickly? How does that data get to your computer, no matter where you are in the world, reasonably fast? So there's 157 requests. If each of these requests had to do a connection setup, that would be 4 round trips. If you're in, say, Australia, that's maybe 200 milliseconds round trip. That's like 3/4 of a second just to load a resource, if we have to go around the world. So you've probably heard that modern content distribution is obviously not going around the world. You maybe have heard rumors that there's like cache servers somewhere deep in your ISP's network or things like that. But how do content delivery networks really work? So today I'm diving into how content delivery networks steer traffic over DNS and over BGP, because I am now running a content delivery network of my own. So I have my own autonomous system number, and that is enough for me to test out BGP-based Anycast. So that's what I'm doing. So if you're interested in DNS, BGP, how content delivery works, then come along in this adventure. Now at this point, I was interrupted by my wizard assistant, who needed some neck rubs before reminding me to tell you guys about how I learned Golang using boot.dev. Boot.dev is an interactive site which helps you learn coding and DevOps topics by working on real projects. So today, I put my lessons to work. I've been studying Golang for a little bit using boot.dev, and I had a need to write a geo-distributed DNS server for this video. So I wrote it myself in Golang, and it's available on my GitHub too if you want to check it out. Their platform also lets you compile and run your code right there, so you can get quick feedback on how well it's working. Now their platform isn't designed to be something you breeze through easily. It's designed to walk you through in great detail all of the topics of the language you're trying to learn so you can master them. Now you can access all of the course content for free, but subscribing gives you access to all of the interactive features like answer checking. Now use my code APPLARD to get 25% off on boot.dev. If you get a yearly subscription, that comes out to only 14 euros a month. Here in Finland. I don't know what that is in dollars, but go check them out. So maybe for a bit more of a concrete example for what's going on here, let's take a look at my own website. Now it's a pretty simple website, not that complicated, but I have a website, applar.net, you're free to browse it, and it is hosted in Ashburn, Virginia, which is about here or so on a map. And I'm located in Finland, which is about here or so on a map. So when I load my own web page from here, it has to send a request to the server in Ashburn, server sends the page back, etc. Now I just loaded my own website and it shows that it did 8 requests, so that's HTML, CSS, resources, stuff like that. And the total data transferred was just shy of 500 kilobytes, so not a lot of data. Let's say I have 400 megabits per second internet here, roughly. 500 kilobytes is about 4 megabits. Give or take. So that should take me, give or take, 10 milliseconds to send all of the data from the server to the client if I'm just limited by pure bandwidth along the way. But it doesn't take 0.01 seconds. It actually takes about 1.6 seconds to load my whole web page, which is not bad, but it's certainly not 0.01. So what gives? The big elephant in the room is latency. So latency is usually measured in the round trip time. So I send a request to my server in Virginia, it sends a response back. Just the time that takes for the packet to flow across the ocean and back is about 120 milliseconds. So in theory, if I send my web request, I say get www.applar.net, send it over 60 milliseconds. It thinks about it, sends a response back, 60 more milliseconds. It also takes 10 milliseconds to actually transfer that much data, so we're at about 130 milliseconds. But that's not where we're at either, because we forgot about how long it takes to set up that connection there. So we have to do the TCP handshake. I send a TCP SYN, it sends back a SYN ACK. Then we can start the TLS handshake. It sends the client hello, server sends back server hello, server cipher, client cipher. Then we've got a TLS session. Then we can send the HTTP request and then get a response back. So 8 packets or 4 round trips. So now I'm up to 480 milliseconds just in time taken to send packets across the ocean to my web server, plus the 10 milliseconds to actually transfer that amount of data. but it actually took me 1.5 seconds. So that's because I was doing 8 requests. Now, generally the requests can reuse the same TLS session, so once we've done the 480 millisecond handshaking time, we can send more requests with at most 1 round trip. We can queue them together if we know about them, but we have to wait for the HTML to load to reference the CSS, and then we can ask for the CSS, etc. So that's what bumps our time up from 480 up to 1.5 seconds. Now, a lot of people would look at this problem of websites loading slowly and say, it's a problem, I don't have enough speed in my connection. Comcast tells me I need their 10 gig network, which they can't deliver 10 gigs over. But anyway, if I were to upgrade the speed of my connection from 500 megabits, which I hypothetically said, to 5 gigabits, that would only push my time down by a couple of milliseconds, because I'm not actually waiting for data to go across the connection here. I'm waiting for packets to go across the ocean. And even at the speed of light, without routing in a fiber, that's still going to take hundreds of milliseconds just for these 4-way handshakes to take place. So, solution is pretty simple. I pick my server up from Ashburn, Virginia. I move it over to Helsinki. Helsinki is pretty close to me. It's probably the closest I could hope for as a server operator. And so now my round trip time is much better. But what about all the people in the US now? Now they get the short end of the stick, because now they're going across the Atlantic the other way to my server in Helsinki. So of course, like many things in computing, the answer is to have 2 of them. So what if I keep my server in Virginia and add a new server in Helsinki or maybe Warsaw or something like that, somewhere in Europe. And now my European people get nice short latencies to the European server, and my American people get nice short latencies to the American server, and the people from Australia cry, as always, I guess. So essentially that's the foundation of modern content delivery networks. How do we get servers closer and closer and closer to the user, so all of these round-trip delays in requesting content get shorter and shorter and shorter, and the users don't have to wait so much time for packets to cross the ocean. Another huge benefit of this is that packets crossing the ocean actually cost a lot of money per packet. I mean, relative to packets like taking local fibers across Finland, for example. So if I can get, as a content operator, if I've got thousands of people watching the same content, and I can move a server for them into Helsinki, then I only have to send that content across the ocean once to my cache. And then from there, it's not taking that cost of transit across the ocean. Now that's not something I'm going to get into in this video because I'm not paying for transit by any of these. I'm just looking at a basic view of how can I get my clients to the right server? How can I steer them to my server in North America and in Europe based on DNS and BGP? And so that's the 2 approaches I'm taking a look at in this video. So now, thanks to scope creep, I have 3 servers around the world, and I need a way to get you guys to the most correct server for your location. And I essentially, as a server operator, have 2 options here. So on one hand, I have BGP, so I could do any cast distribution. And on the other hand, I have DNS. That's why I wore my DNS shirt here from Jeff Geerling. Let me know if you guys think I should make a It Was BGP shirt too, because it's always one of those 2, right? BGP or DNS. So since most of you probably have no idea what BGP is, or maybe if you follow my channel you do, you probably do if you follow me, but most of the normal people have never heard of BGP before. It is the routing protocol that forms the backbone of the internet. So I have an address, for example, 2AOF B240 1000:420. And if you were to go to this address, it is my server. But which server is it? It's actually all of them. So thanks to the magic of routing, all 3 of my servers advertise that they have the address range containing this address, and they're able to access it. Now they're not actually literally the same server, they're just claiming to be the same IP address. And through routing and BGP, you'll get to whichever one your network finds the closest. Now, the closest has nothing to do with geography, and has everything to do with going through the least number of companies. So I am an autonomous system, I have an AS number 201726, and I'm advertising out these prefixes to the world through my upstreams, Vultr and RackGenius. They're then advertising out to their upstreams, so that's primarily Aurelian, Hurricane Electric, and 123net. So let's take a look at how my network looks now in BGP. So I'm using bgp.tools here, which is a great viewer. So I already made a video before on how I set up my autonomous system and got my prefix space, so link up here for that for a bit of a refresher. But basically, I have 3 servers in the cloud. I have a /40 prefix space allocated to me. I can advertise out up to /48s from there. 48's the smallest prefix we allow on the DFC. So for any cast, I have to advertise out a /48, even though I only want one address out of that. And so back here looking at this prefix. So I am the origin here, AS201.726. I'm advertising to my two upstreams. So 32002 is Rack Genius and Grand Rapids. And then 20473, that's Vulture. They show up as constant. And so this shows how it propagates to their upstreams. So Vulture is paired with Cogent, Aurelian, and GTT. And so I'm advertising to these three via them. They're also advertising to Comcast, who's getting me to Orange. And then down here on Rack Genius, they're advertising to 123net, which is 12129, who's averaging me to Tata and Zayo. And then they're also going directly to Hurricane, 6939. And then all of these guys over here, if you're paired with one of them, you'll have to go through someone else. So AT&T looks like they're going through Aurelian. Lumen, which is, I believe, the biggest AS in the world, they're paired with Tata, GTT, Aurelian, and Cogent. So I guess you're more likely to take one of these routes. I'm not entirely sure. But and then Deutsche Telekom is going through GTT, and then NTT is going through GTT and Aurelian. So basically, if we look at these Tier 1 ISPs in the blue here, if your ISP is paired with, they're probably paired with at least one of these Tier 1s. Maybe 2 or 3, depending on how big they are. So if you're a small regional ISP in Finland, you might only pair with Aurelian, for example. They're from Sweden, so they're kind of from here. If you're a national ISP, you're probably paired with most of them. And so whichever one of the Tier 1s you're more closely paired with is essentially what route you're going to take to me. So if I'm advertising out via Aurelian, Cogent, and GTT from my server in Warsaw and my server in Los Angeles, and you're paired with, say, GTT, you're probably going to take my server in Los Angeles or my server in Warsaw over my server in Grand Rapids, which is paired through Hurricane and 123net. On the flip side, Hurricane is very easy to peer with. So many ISPs have Hurricane peerings, which means they end up going to the server in Grand Rapids that's paired with Hurricane. So I don't have direct control over these advertisements, but I have a little bit. So I can signal to my two upstreams here, Vulture and Rack Genius, how I want them to advertise out to everyone they're directly connected to. So let's take a look at how that works. So Vulture, for example, has this guide in the BGP communities they support. So some of these they'll assign to their routes, and some of these I will assign to routes that I send to them, such as these actual ones here. So I could say 60473, 6000, 6939 to not advertise to Hurricane, for example. We can prepend 1 time, 2 time, 3 time, which makes it appear like a worse route. And we have other options on how we want to control what they advertise to their upstreams here. So using these communities, I can tailor a little bit how I advertise these routes out to the world. Let me show you how I've done that for my 3 servers. So first up, this is Warsaw. And in Warsaw, I am advertising everything with no community. So I want it to be the best route possible to everyone. And so the Warsaw server is only uplinked via Aurelian, I believe. Maybe also through Cogent. It doesn't have as many uplinks as Los Angeles. And I really want most of the traffic that sees Warsaw as a valid option to go to Warsaw, because I'm getting a lot of traffic funneled across the Atlantic in the east to west direction, and I'm not getting a lot of it funneled in the west to east direction. So I want to make my server in Warsaw look more attractive. On the flip side here in Los Angeles, I'm doing a whole bunch. So I'm prepending to Cogent, I'm prepending to level 3, I'm prepending to NTT, and I am prepending to AT&T. And so this one, well, I guess these guys are just blocked. So NTT wasn't listening to prepending, so I just don't advertise to them directly anymore. AT&T was happy to carry my traffic across the Atlantic, and these two guys weren't peered in Warsaw, so again, they were carrying a whole bunch of traffic across the Atlantic. So adding a prepend just means that we add a fake AS number in the path to make it appear a little bit longer and a little bit worse. So if you're peered with, for example, NTT, well, I blocked them. If you're peered for level 3 and Aurelian, both together, normally those routes would look identical, and it would pick one based on whichever carrier is cheaper, probably. But I want to sway it a little bit back towards Aurelian, so we end up more in Warsaw, and so I do a prepend there. And in Grand Rapids, again, we're only prepending to Hurricane because we're getting too much traffic across the Atlantic from Hurricane, but everything from 123 is fine. So that's how I'm doing traffic engineering for my BGP. Now, one other option that's available to larger ISPs and larger content networks, but not to me, is route servers at internet exchanges. So most countries have at least a couple internet exchanges. Like in Finland, we have a big one in Helsinki and a smaller one in Tampere and Oulu. And so an internet exchange is basically a really, really high bandwidth switch, so layer 2. And different companies that are providing content or serving content can peer together over this switch together. So if I'm like a content delivery network, I could buy a 100 gig port into the switch. And then if you're a network that has users, you could also get 400 gigs into the switch or something like that. And we could peer across that network. But if there's 5 ISPs there, I only have to use my 100 gig port for that. I don't have to individually sign agreements with all of you separately. I'm just sharing my routes to the route server at the internet exchange, going across the internet exchange's fabric, and everyone can mutually benefit from that. And so usually internet exchange routes don't include global internet routes. They're just companies that are located at the exchange. So if I am Cloudflare or I am a CDN and I'm at the exchange, I'm sending out my routes to everyone, but I'm not handling my global traffic through the internet exchange. I've got some other agreement for that with a transit provider. So if you're an ISP, these IXs tend to be really, really cheap because you're not paying to connect. And if you're a content delivery network, you really want to get on all the IXs so that you get to all these ISPs easily. And so IXPs will generally have servers, edge servers from just about every CDN network and as many local ISPs as are able to get a connection into there. Because then everyone avoids paying for the tier ones, which all have a transit cost associated with it. But I'm not in any data centers that have IXs, so I can't interconnect there. I would need to get a VPS like in Helsinki or probably in like Amsterdam or something like that to be part of an IX. So maybe that'll be part of a future video. But for now, this is what I got going on for BGP. I probably could do a little bit more tweaking to advertise my communities differently, advertise my routes differently. But this is how I'm steering traffic with BGP right now. So I guess let's take a look at DNS. So over here in Team DNS, things work a little bit differently. So back in BGP, I was routing based on IP addresses, but in DNS, I'm operating based on names, and also I have a whole tree to recurse. So that could take some time, and I have a number of different places where I can play with it. So let's take a look at how the resolution for my CDN actually works. So to start off, I'm going to do a search for geo.applr.net, that's the domain name, and I'm going to ask it for a quad A because that's an IPv6 record. And what do I get? I get this guy. So this is in the 1001 subnet, and it looks like it came from this resolver, whoever they are, and they figured it out for me. So most of us think of DNS, that's what we think of. I queried my DNS upstream and it gave me an answer. But that's not actually how DNS works. We actually have to recurse down from the root, or someone has to recurse down from the root. Most people are probably using the server provided by their ISP, which in this case is a good thing. Or maybe they're using Cloudflare or maybe Google or something like that. So let's take a look at how real recursion works. So now instead of asking my default server, I'm going to ask a specific server. So I'm going to ask h@rootservers.net. So these guys hold the DNS, like the whole DNS. So we'll ask them, and they don't know the answer, but they know that one of these 13 servers here at gtleservers.net probably does know the answer, because these are responsible for net. And then they kindly gave me the IP addresses of those servers, so I don't have to look them up. So now if I pick one of these again, GTLE servers, we ask them, and they tell me, again, they don't know the answer, but one of these servers does. So applr.net is hosted by these 3 at Hetzner, so we'll pick one of them and ask them. So I pick Helium, I ask Helium. Helium now says, you've asked for geo.applr.net. And I don't host that either, but grre1.applr.fi does. So now we got to ask grre1.applr.fi. So again, we query grre1.applr.fi, and it tells us the answer. So DNS is made up of these trees where we keep asking new servers. And anytime we have a dot, we could potentially get redirected to a new server. So we have the root dot, the root servers, we have net, we have Applard, and then we have geo. And each of those came from a different server. So I can create custom responses either at the Applard layer or at the geo layer. So since I don't have the ability to do that with Hetzner, I wrote my own DNS server that runs on the Grand Rapids server that figures out what response it wants to give you based on your query information. So if instead of asking for a quad A, I ask for a text, it'll give me a bunch of information. So let's ask for a text instead. Okay, so we got a bunch of information here. We've got the geo information. It says I'm in Finland. The ASN was registered in Finland. It's on the European continent, and it is part of ASN 719. And I hit a rule called Europe to WoW. So what that means is that first I got the results of the GeoIP database that I queried. I queried both the IP address and the AS number. And then secondly, I have like a rules like if then, if then, if then, if then. And I hit the rule named Europe to WoW, which means since I'm on the European continent, I get sent to the server in Warsaw. But what if I were to instead query this via like Google DNS, 8.8.8.8.8? Do I get a different answer there? So that means that I acted like I used Google as my resolver. And a lot of people are probably using like Cloudflare, Google, Quad9, something like that as their resolver, especially for viewers of my channel. But that means that now, as a DNS server, the IP addresses I'm getting aren't coming from the clients, they're coming from Google. So we can see that here. We get origin geo. So it's from Finland still, but it's registered in the US, and it's from AS 15169, which is Google. But it included this ECS, EDNS client subnet, that says I'm actually from Finland, and 719. So Google was kind enough to include part of the original IP address in the DNS query, so my server could then geolocate based on that. Now that's something that Google does, but it's not something everyone does. So what happened if I do Quad9 instead of Google? So now if I want to do 9.9.9 instead, then I don't have that ECS because Quad9 doesn't support ECS. So while I might have a much better chance of geolocating correctly based on DNS as opposed to BGP, I still have the problem of not knowing how related the user is to the DNS server. So if I'm making queries to Google's DNS servers, how close are Google's DNS servers to me? And I'm really geolocating that DNS server and not the actual client. So this time I'm going to ask it, but I'm going to fake my client subnet. So what do I get now with a fake client subnet? So now it told me that's registered to AS3389, and they're in the US, and so I should geolocate to the US. So now the rule told me it geolocated based on Los Angeles. But my origin query still came from Finland. So this is the kind of thing that a lot of like shady VPN services do. They want you to feel like you're actually from somewhere else in the world without actually sending your traffic around the world because that costs money. So maybe they do stuff like this, I don't know. So then to actually like do this, I wrote this single Go file. It's not that long. And this is basically what's my DNS server. So somewhere here I have the DNS function, handle DNS request. And so in handle DNS request, I check and see if it's a request type I can handle, if it's the correct domain name, because we can only return our correct domain name. And then somewhere down here, I find what rule I'm in. Yeah, so here I'm going over the list of rules and I'm seeing if they match continent, etc., and matching with a rule. And so rules are just defined in YAML, and this is what my rules look like. So I send everyone from Canada to Grand Rapids because I thought that was better, I guess. If you're from a big American ISP, so this is like AT&T, Comcast, one of these is Starlink, then you get sent to Grand Rapids. If you're in Europe or Africa, you get sent to Warsaw, and everyone else gets sent to LAX. So one of the downsides to DNS-based routing, I'm just using the country here in my database. So I can't tell if you're from the East Coast or the West Coast of the US because I don't have state information. So if you're from Michigan, you might get sent to Los Angeles instead of Grand Rapids, which is not the end of the world, but it's something BGP might do a better job at, especially if I had a presence at IXPs. But this is what I can do. Everyone else to LAX actually catches a lot of people. So if you're in Asia, South America, that kind of stuff, you're going to go to LAX. And generally, peerings across the Pacific are better than going across the continent to Europe. So a lot of Pacific Asian ISPs have strong peerings across the Pacific to Los Angeles, to San Francisco, stuff like that. So a lot of that traffic will have a better route to Los Angeles than it will to Warsaw. If you're down under in Australia, I'm sorry, your latency is just terrible, but it is what it is. So I guess the last thing to do is figure out which one's actually better. Are you on Team BGP or Team DNS? So about a week ago, I sent out a link to my followers on Discord and on Mastodon and asked them to load a page on my website that would show them a bunch of cool statistics. That would also submit to my end the latency they received in the connection between their browser and my CDN over DNS and also over BGP. The connections obviously run over HTTP with TLS, but it's the server they were directed to via BGP or the server they were directed to via DNS. And so I have about 1,000 statistics that were reported from that by different people. You're free to go there as well. I guess I'll keep that updated for a couple days after the video goes live. But so now with about 1,000 instances of people loading my web page and pinging the CDN to see what their latency is, who's actually the winner? So I got this cool page on my website that's going to go live when the video does, you can see. So it looks like DNS 71 milliseconds and BGP 114. This is the median for both, not the mean. So that data is from 933 records across 52 countries, 189 autonomous systems, and 7% of them supported ECS. I guess it might be another neat statistic to see how many people are using their ISP's resolver. So like when the HTTP query and the DNS query came from a different autonomous system, that would indicate you're using like Quad9 or Google or Cloudflare or something, because realistically web requests aren't going to come from Cloudflare or Google. So scrolling down a bit, I've got it sorted by country. You can group by country or ASN. So look at who's the best here. So someone in Poland is the best. That makes sense because the server's in Poland. So these guys at 13 milliseconds, that's really, really good. And then who's doing terrible for ASNs? Australia, the Aussies. Yeah, that makes sense. I'm sorry, guys. So this chart shows just the absolute latencies, DNS and BGP. And we sort by the average of those two. You can group by country or ASN. You can also filter to continent if you want. So just got... So like Europe, who's the best in Europe? Serbia is the best in Europe, I guess, on average. Slovakia, the worst. Interesting. And then down here we have the difference between BGP. So green means BGP fast, or green means DNS faster, and red means BGP faster. So again, we're grouped by country. So it looks like Qatar is doing terribly at BGP, but DNS is not bad. So something about the routing there is not fun. Down here in Saudi Arabia, their DNS-based routing was quite poor. So I'm wondering why that was. I wonder if Saudi Arabia is not counting as Africa or something, so it's taking them to LAX, or I don't know. I guess I could look at the detailed results to see these specific records. So grouped by ASN again, so these guys in the US are doing really bad at geolocating BGP, I guess. I don't know why. And Jean-Eric Ortigue, that's a personal ASN, his DNS latency is quite bad. I wonder why that is. I don't know. And Saudi Telecom, we figured they'd be bad. So while this whole thing is generated in real time in your web browser, the data source for it is a CSV on the web server that I am updating manually from the DS server periodically. So the DNS server stores sensitive information in memory. So request IP addresses, those are considered personally identifiable per GDPR. So to avoid transferring them, I'm keeping them in memory in the Golang process. So when I write them to disk, I'm stripping the IP addresses from the records. But I could still have other information in there, like someone appeared to have a translator because the text came back Japanese. So for some reason, I don't know why I'm not very good at JavaScript, it actually sends the string from the web page instead of like the number saved as a variable somewhere. So if you modify the web page, then they get sent to me, so I can strip that out. And also invalid requests. The whole CDN only works over IPv6, so in theory you shouldn't be able to submit a request over IPv4 because it just won't be able to load that endpoint. But if you managed to, or you had errors in the request or something, I can remove those from the file manually. And so then I upload that to the web server, it comes here filtered, and you guys can view it. So I'll do that periodically, or maybe I'll set up some automation that checks for invalid entries and parses it and makes sure it's valid and not just what came out of the post request. But yeah, so that's you're free to view it and explore it if you want. Like I said, the data is a CSV, which you're free to download if you just look in the JavaScript and see where it is. Oh yeah, so real CDNs would combine these two in some way. So they might be advertising any cast out of a specific region, and then in that region doing any cast across all their different points of presence or edge nodes or things like that. They also do a technique called CNAME chaining, where essentially you can, instead of returning a result, you can return a CNAME, which means you're pointing to another resolver somewhere else. So my global resolver could point to a local resolver that has more specific information or things like that. Then you get anycasted to a resolver that's, or a server somewhere close to you. There's a number of different techniques that real CDNs can use to optimize this better than I have. But this is me learning how CDNs work by building my own on the real internet. Thanks to boot.dev for sponsoring this video. Using my new Golang skills, I wrote the DNS server here, which is available on GitHub, by the way. It doesn't have the post request parser that handles the statistics. It's just the DNS serving. That part's open source, so feel free to check it out if you want. Feel free to look at my blog, link down in the description, for this cool visualizer of the data. Maybe the data will be updated soon. I don't know if a bunch of you guys view the My IP site, which also has a bunch of really cool information about your DNS request, by the way, if you want to see that. If you want to chat with me more, link to my Discord server down below. If you want to buy merch from me, merch stores on my Ko-fi down below. It may have the It Was BGP shirt. I don't know if I'll have pictures of it in time, but if it's live, I guess you'll see it. And I guess I'll see you guys on the next adventure.